of tungsten. And while emitter is made up of, so there's a platinum. This is the emitter, and this is a collector. No, photoelectrons are ejected. These photoelectrons, so these are the photons, and these are the electrons here. Do we have anything like an electron beam? This is like electron beam. Fast moving electron beams when strike the tungsten. So do we get X-rays? Yes, there'll be an X-rays here. So here is what we'll get X-rays. I think the problem is something related to of this kind. There's a light, electron beam, and again we'll get X-ray. X-rays also. So this is some let me call EM wave or something. Monochromatic radiation of wavelength. I think 1000. So instead of calling this wavelength of this 124 Armstrong. Don't call light. It's not in visible spectrum, so we don't call it light. What all the things I'm just mentioning here. Okay, now getting to the problem. And power of 100 watt is incident on emitter which emits photoelectrons with a quantum efficiency of 1%. The exciting voltage across the photo cell is of 10,000 volt. This is how much? 10,000 volt. The power supplied by the exciting voltage. Work function we know, 10 electron volt. Incident wavelength we know. So what all the quantities we know, first we'll list out. So work function is what? 10 electron volt. Incident wavelength 124 Armstrongs. Can we get any saturation current? Yes, there'll be a saturation current. So what is the power of this photocell? It should be equal to V naught into IS will be the power. How to calculate saturation current? Power of 100 watt is incident. So what is the power? Power of light beam is there. So can we calculate the overall the saturation current? Any formula for saturation current? Quantum efficiency, power of source, lambda, charge by SC. Will I agree this? What is E? E is a charge of electron. Eta is quantum efficiency, power. Power by energy of photon. Okay, let me write here. PS by SC lambda will give number of photons incident. Then multiplied with eta will get quantum efficiency into E will give the saturation current. So now we know saturation current, we know accelerating voltage. What is the power of photocell? This should be equal to V naught into IS. So there's the one thing. The minimum wavelength of radiation coming from the tungsten target. How to get this? So what happened to these ejected electrons? They're accelerated, no? Himself is telling accelerated. Himself telling is being accelerated. So this end should be positive, this should be negative. The electric field here will be in this direction. This electrostatic field, what will accelerate it? So by the time it reaches here, what will be the kinetic energy of the incident electrons? Called K dash. Here they'll be ejected with K max here. So from what is K max? K max you can write it as SC by lambda minus work function. The kinetic energy of electrons reaching the collector of the tungsten, it should be equal to K max plus into that accelerating potential, no? EV naught. This K max, this K dash should be what? SC by lambda. Okay, so sorry, this one he's asking the minimum wavelength of this one. So this k dash is what we can write as SC by lambda. So k max plus EV naught. I try to see. I'm writing the equations like this. Solving will get the minimum wavelength. Shall I write lambda minimum? The minimum wavelength of radiation. You have to work out for that particular. The power supplied by the exerting voltage. I think A and C you can eliminate. You can verify from this discussion what I made. Power of a photocell. Minimum wavelength, the minimum wavelength of radiation. I think the AC and BD, just checking for this one. So I'll write down the answer. So this should be the 100 watt. 1.23 Armstrongs. This is another option. Do calculation later on. Huh? Okay, then be careful. Some questions like this with photoelectric effect X-rays also. Fast moving electron beam, if they get accelerated and then strike a junction again, we'll get from there the X-rays here. Okay, now we'll go for reduced mass concept. Until now, the atomic structure, what we discussed, it was only related to the nucleus, which was a test. No? So let's go back. So what the atomic structure, what we had is, this was a ZD, and the electron was revolving.